Okay, now we're going to talk about the Black-Scholes model, or Black-Scholes pricing formula. Black-Scholes model is the most widely used option pricing model in the world. There are some variations to it that have been developed because it's, like most models, it's not perfect. The it uses a normal distribution, which we know that stock returns are not normally distributed, but uh, it is a very effective model. So we're going to walk through it here. There are uh, I'm not assigning any problems, but I believe that understanding of the model to some extent is valuable for our purposes. So anyway, so the value of a call option, this is in continuous time, is simply equal to the stock price multiplied by the E. E's the 2.71 something. It's a and that's the exponential. It's to the power of negative delta, which is the dividend rate multiplied times time, and then ND is just some normally distributed random draws. The basically what it amounts to is it's basically the probability that the likelihood that the option will be in the money. Then we subtract out the strike price again, E the exponential, so that's 2.71 to the power of the minus the risk-free rate multiplied times time, and again in D2 we'll see the the, the derivation of D1 and D2. The next page describes each of the variables uh, slightly better. The definitions in the book are a little more detailed. So C is the current call option value. S0 is the current stock price. ND is the probability of a random draw less than D. Again, that translates roughly to the probability that the option will be in the money. X is the exercise price. E is the base natural log function, roughly 2.718828. Your calculators have an E function. The Excel has an exponential function as well. The delta, again, the annual dividend yield, the underlying stock. R is the risk-free rate. T is time until expiration. Ln is a natural logarithm, and sigma is the standard deviation of annualized continually compounded rate of return. So if we go backwards, we can look at D1 and D2, and if you look at this formula, the one thing you'll notice that D1 and D2 both will go up as stock price goes up, and what that means, the higher the stock price is, the more likely it is that the call option is going to be in the money, and the as a result, the value of that option is going to be greater. So we look at a probability distribution, look at D here, the probability of a random draw less than D, again translating to the likelihood that that option will be in the money. So the greater this value, the more area is shaded, the greater the likelihood that option is going to be exercised. So Black-Scholes pricing formula relies on implied volatility. Simply the standard deviation of stock returns consistent with the option's market value. So, the pages, or slides 17 and 18, show Excel models. These models are available on the Connect website. If you would like to see these models and you don't have access to the Connect website, I would be happy to share them with you. We're not going to work with them or walk through them today. So the Figure 16.5 tracks implied volatility of the S&P 500 from 1990 to 2017. You can see here with implied volatility generally is somewhere between 10 and 20% during normal times, but it goes up considerably when we have economic or political turmoil. The Gulf War implied volatility went up to 30%. Long-term capital management was a hedge fund that failed that went up to 45%. Long-term capital management was a very highly thought of hedge fund, and it failed as a result of some bets on interest rates that went against it. And then we had 9/11 and Iraq War were around 40%. Financial crisis, not surprisingly, that was about as high as implied volatility got to. And finally, here we see the when the U.S. debt was downgraded, implied volatility went up to about 45%. We'll continue with more on the Black-Scholes model on the next lecture.